Alright, section 1, 2, part 2. If you remember in part 1 we talked about the identity and the inverse. Now we're going to talk about some properties of addition and multiplication specifically. Our objectives this time, the first thing we're going to do is determine if a set is closed under an operation. We're going to talk about what this word closed under an operation really means. Then we're going to understand commutative and or associative properties and determine if they apply to an operator or not. And we're going to explain and apply the distributive property. So a couple of objectives here. Let's get started. Alright folks, let's think back to the first lesson we talked about whole numbers. What are we talking about here? Remember whole numbers, we looked at the categories of real numbers. We had natural numbers, whole numbers, then we had integers, rational numbers, and then we were at real numbers, and then over here by itself was the irrational numbers. So we talk about whole numbers, we're talking about this category here, which starts at 0 and increases by 1 all the way up to infinity. No decimals, no negatives. But we want to classify even further. I want only the even whole numbers. So let's list some of those inside this box. I'm going to have 2, 4, 6, 8, 10. For those of you paying attention, you may realize that I didn't start with the number 0, and it's a good catch. And that begs the question, is 0 even or is it odd? Well, it turns out there was a little bit of discrepancy during a recent hurricane when the governor of New York, or maybe it was the mayor of New York, I have it a little bit mixed up, but they said that only cars with even license plate ending numbers could fuel on this day, and only cars with odd ending license plate numbers could fuel on this day. Well, those with a 0 as the last number in the license plate were pulling into lines, and nobody was quite sure whether or not they were supposed to be there, so they just let them go. Well, it turns out that by definition, 0 is an even number. And we can talk a little more in class about why that is the case. But 0 is in fact an even number. So when I talk about the even whole numbers, we have 0, 2, 4, 6, 8, 10, and it goes on and on and on. So we talk about closure. Closure is another one of those things, just like identity or inverse, that we need to have an operator to talk about. We say, is this set of numbers, even whole numbers, closed? Well, we have to specify, is it closed under addition? Let's take a look. If I say something is closed under addition, if I say a set is closed under addition, I mean, if I take any one number, we'll just call it n1, plus any other number, n2, it's going to still be an element of the set that these two numbers came from. We're still going to be in that set. Let me be a little more specific here. If I have an even whole number, plus an even whole number, if it is closed under addition, I should end up having an even whole number. Let's try it out. 4 plus 6 is 10. That worked. 2 plus 6 is 8. 8 plus 10 is 18. 0 plus 4 is 4. So anytime I add any two numbers from this set, I stay inside the boundaries of this set. We could say that this set, even whole numbers, is closed under addition. Well, let's try subtraction. That's another operator. Is it closed under subtraction? If I were to take 8 minus 6, well, that equals 2. That seems to work out pretty well. What if I took 6 minus 8, though? 6 minus 8 is negative 2. And if we look at our set over here, negative 2 falls outside my ring. So it is not closed under subtraction. And we're going to find that a lot of things that are closed under addition or multiplication will not be closed under the inverse operations of those two. So it will not be closed under subtraction, and it won't be closed under division. Not always true, but most of the time it's going to be true. If I did multiplication, is this set, even whole numbers, closed under multiplication? Yes, anytime I multiply one number in this set by another number in this set, I result in a third number or another number that is also in this set. 2 times 4 is 8. 4 times 6 is 24, and 24 is an even whole number. And again, if I do division, I actually jump outside. So 8 divided by 4, that is 2. But what's 2 divided by 4? It's 1/2. And 1/2 is not a whole number, it lies outside. So it is not closed under division. Alright, so that's our first topic there, closure. Now, let's talk about the first property that we're going to address. And again, we need to talk about the operator that we're using when we talk about this property. So let's talk first about addition. When I'm adding, is something commutative? When we can think about commutative, I'll show you my great artistry skills here, ladies and gentlemen. Please hold your applause to the end, and I will sign autographs of personal art copies if you so desire, but you probably won't. If we have a train here, this conductor, there's the train engine. Look, I'm even going to give it some smoke. All right. Now, if I have this train engine here, and let's say I've got a black car, and I have a blue car, and I have a red car. Well, when we're looking at this train, there's only one railroad track that all these cars are going to be on, right? They're all going to be hooked together. Well, when we think about commutative, we can think about commuter trains. If I were to take these cars and move them around, rearrange them in a different order, they're still going to go to the same destination. I can rearrange them as many times as I want to behind the same operator, the same train, right? Same train engine, and they're still going to get to the same location. Well, when we look at addition, let's see if addition follows this rule. Is it commutative like train cars? If I have 3 plus 5, what's that equal? It equals 8. Well, if it is commutative, I could rearrange my train cars and I could get the same answer. So in this case, the equal sign is kind of like my my locomotive here, my train engine, and my cars are the 3 and the 5, with the operator being addition. If I leave my operator in place and I switch the position of the cars, do I arrive at the same location? I certainly do. So addition is commutative. Check. Let's talk for a minute about multiplication. Is multiplication commutative? Again, let's set up a problem here. Let's go with -2 times 3. Well, we know that -2 times 3 is -6. What if I take my two cars here? Again, my equal sign is like my locomotive. My two train cars are -2 and 3. My operator is stuck between them here. Let's keep the operator. Let's switch the position of the train cars and see if we get to the same destination. 3 times -2, what does that equal? It still equals -6. Multiplication is commutative. I could rearrange the order of what's being multiplied. Even if I had 12 things all laid out, I could rearrange the order. When I multiply them all together, I'm still going to get to the same answer in the end. So again, let's look at subtraction though. Is subtraction, let me change colors here. is subtraction commutative? Well, we use our numbers up here. 3, well, let's do 3 minus 1. We know that equals 2. So if subtraction is commutative, I should be able to rearrange and go 1 minus 3. What does that equal? That actually equals negative 2. So if I change the order of the cars, I don't get to the same destination. Subtraction is not commutative. And the same thing with division. If I change the order that I divide numbers in, I don't get the same answer. Division is not commutative. Now let's talk about the associative property. We'll look at addition first. Associative property. Now we could think about the associative property. The commutative property back here has to do with the order that things come in, how they are ordered. Changing the order doesn't change the answer. That means the operation is commutative. When we talk about the associative, we could think about a lot of people. Let's go with 3 people for now. 3 plus 4 plus 2. Well, here I have 3 different people represented as numbers. If 4 and 2 talk together first, and then they talk to the number 3, or if 4 and 2 are added together first, and then we add the number 3, let's see what we get. 4 plus 2 is 6. 3 plus 6 equals 9. All right. Now, if I leave the order the exact same, still a 3, a 4, and a 2. But I change the way that they are associating. If the 4 and the 3 talk together first, I get 7. 7 plus 2 is still 9. And I could do this with any 3 numbers and change where my parentheses are, not the order. Realize I got 3, 4, and 2, 3, 4, and 2. And I'm going to end up with the same answer. So I could change what numbers are associating together first, and then here 4 and 2 associate first, and then we add 3. And here 3 and 4 associate, they add first, and then we add 2. But we still get the same number. Addition is associative. Now let's look at multiplication. If I have 6 times 2 times 4, and I'm going to use dots on this one to be a little bit clearer. 6 times 2 times 4. Well, if I have the 2 times 4 first, 2 times 4 is 8. 6 times 8 equals 48. Nice little rhyme there. 6 times 8 is 48. If I write the same numbers in the same order, but this time 6 times 2 first. 6 times 2 is 12. 12 times 4 is 48. That works. And it turns out, ladies and gentlemen, it doesn't matter what numbers I choose. If I multiply in the same order, I can reassociate and multiply any 2 numbers before the third number and get the same result. 2 times 4 times 6 is the same as 6 times 2 times 4. We both get 48. So again, commutative has to do with changing the order the numbers are in, and associative has to do with changing what 2 numbers we operate on first. Now, here's a big concept. Distribution. A lot of you are familiar with it, but we're going to cover it again. We talk about the distributive property. If I have 3 times 5 plus 2, what's that equal? Well, if we look back to the order of operations, the order of operations says to do parentheses first. Let's try it that way to start with. 5 plus 2 is 7, and 3 times 7 is 21. Okay? But I can use the distributive property to solve this a different way. Since I have a number multiplied by a sum, I could say I'm multiplying something over addition. I could multiply each of these numbers by 3. I would get 15 plus 6, and then add them, 21. Let's try it again with a different one. And I'm just making numbers up here. What about negative 2 times 8 plus 6? What is that going to give me? Well, we know, let's check it first. We know that 8 plus 6 is 14. What's negative 2 times 14? That's negative 28. If I use distribution, I can distribute negative 2 over the sum, multiply each of them by negative 2 first. I get negative 16, and negative 2 times 6 is negative 12. When I combine those, I get negative 28. So I end up with the same answer. You may be saying, why is this useful to me? I could just use the order of operations. But in algebra, remember folks, we're dealing with unknowns a lot. So let's say, instead, we have 3 times x plus 2. Well, order of operations says parentheses first, but it's already simplified as much as possible. I can't simplify x plus 2 anymore, but I do have a number multiplied over addition, so I could write it as, simplify it as 3x plus 6. Now I'll bring up 2 points here really quick. What about 4 times x minus 5? Well, I said it has to be multiplied over addition, right? But remember, we can think about subtraction as adding a negative. So technically, we could write this as 4 times x plus negative 5, and it's still 4 multiplied by x plus negative 5. It is 4 being distributed over addition, which would be 4x plus negative 20, or 4x minus 20. Now this is a whole lot of unnecessary steps, but I wanted to show you that really it is still a number being distributed over addition. We could jump straight to this step, 4 times x minus 5, distribute that 4 in here, and get 4x minus 20. Now I've got my be careful sign out, and I want you to be careful for a number of things. First of all, when we're doing distribution with a negative number, make sure you take that negative and you apply it to both your products. So it's negative 2 times 8 and negative 2 times positive 6. Watch your signs and be careful. But the big thing I want you to be aware of, ladies and gentlemen, this huge be careful is, don't advance the slide till you're ready. No. The huge be careful is, we have to distribute over addition only. Now think back to our associative property. If I have the number 3 times 4 times 2. If we do this by order of operations first, I'm going to get 8 times 3, which is 24. I cannot distribute 3 onto the 4 and the 2. I can't distribute it because to distribute it has to be over an addition problem. This is a multiplication problem. If I do this, I get 12 times 6, which is 72. I've done something wrong because 72 does not equal 24. I cannot distribute onto multiplication. I can only distribute over addition. Ladies and gentlemen, this will become very key, and it's a little bit more obvious sometimes when we talk about 3 times 5x. Well, all it is 15x. It's not 15 times 3x, all right? Be careful. You have to have an addition inside your parentheses in order to distribute. You can only distribute over addition. And remember that subtraction can be viewed as adding a negative, so we can distribute over subtraction as well. Now let's take a minute and look at these properties. Which property is represented in this first problem? Well, we're dealing with addition, so it's going to be something of addition. What is it? Let's think back to commutative changes the order. Associative changes where the parentheses are but keeps the same order. Here I've got a 2 plus a root 3 equals root 3 plus 2. I've changed the order, but addition is commutative, so it will actually be true. This will be the commutative property of addition. I'll write it out all the way. Commutative property of addition. Now what about here? I've got pi times 2 plus root 8. Well, I'm distributing pi over addition, and it becomes pi 2 plus pi root 8. This is my distributive property. In this problem, 9 times root 2, or root 2 times 9, they do equal each other because multiplication is commutative. I could change the order that the train cars are in and get the same answer. I should be a little more specific here. Commutative property of multiplication. And here, let's be careful, folks. This is where I wanted you to be careful. If I have 9 times 12 pi, and it equals 9 times 12 pi, don't you dare say distribution. Folks, this is associative. I kept the same order, 9 and 12 and pi, 9 and 12 and pi. I just changed where the parentheses were located at. Here it's 12 times pi times 9. Here it's 9 times 12 times pi. This is the associative property of multiplication. And here, a little more obvious maybe, and maybe a little tricky because my negative is thrown in here. This is addition. I'm adding a negative 6. Here I'm adding 3 plus 6 and then adding negative 6. In this case, I'm adding 6 and negative 6 and then adding 3. I've got the same exact order. I've just changed the grouping. So they're grouped differently, same order. It is the associative property of addition. That one went a little bit longer. I do apologize. But good luck on your concept check, and we will talk in class tomorrow.